Okay, so what's different about water's phase diagram? There's a negative slope of the great. What implications does that have?
It allows ice to float.
Okay. Do we know what the temp where it's most dense is?
Yeah. 4 degrees.
4 degrees Celsius. All right. Okay, so we're going to draw a phase diagram here. And I have pressure over here. And I've got temperature here. Wait, what are we doing? Water?
Yeah, so it's got to be
Alright.
cans of beer over there.
Solid, liquid, gas. Melt. Freeze. Vaporize. Condense. Sublime. Deposit. And then triple point. And critical point. Is that it? I guess I didn't ask for that part, but that's fine. Oh, okay, so 4 degrees Celsius. And what happens if you raise or lower the temp?
The density actually goes down.
Okay. All right, so explain the swimming pool ears hurting thing.
Isn't it like the pressure in the water outside is greater than the pressure in your head?
Okay, so so when the pressure's high like that, what happens to the eardrum?
It stretches to
It's pushed inward.
Yeah, it's gonna bow in like this, and then that causes pain. Any deviation in the structure of that eardrum is gonna be felt as pain. All right, so we've got some magnesium metal and some copper 2 chloride. So Mg and CuCl2. And so you're aqueous and you're solid, and then you're some solid copper, and then you're some magnesium chloride, and you're aqueous. So how do I know that the copper 2 chloride is aqueous?
there's a rule for chloride.
Yeah.
Say again?
There's a rule for chloride.
Chloride rule.
Okay, that's how I know that it's going to dissolve. Sure, that's. How do I know that it's wet at all, though?
Is it able to react with solid?
Yeah, magnesium solid.
Why don't I just throw it in there as a solid?
So wouldn't do anything.
It would just sit there, right?
Right.
Because that copper 2 chloride is a salt, so it's just throwing some metal on some salt, and nothing would really happen except for the metal that's actually touching that salt. So I'd only get the surfaces to react, and then everything would stop. Okay. So this is a single replacement reaction. Is this also a redox reaction?
Yes.
Yeah, how do you know that?
Because all of the reactions are redox unless they're double replacement.
This one definitely is. They don't all have to be. They just almost always are.
Okay.
How can you look at this one and tell for sure?
Because the copper that was attached to another thing isn't anymore.
Broke off.
Okay, so on the left-hand side, the copper has a charge because it's in a compound, and on the right-hand side, it's by itself, so it has no charge. Yeah. And then the magnesium has no charge on the left side, and on the right side, it has to have a charge. Okay. I want to figure out what's going to be left in this container. So I'll just start off with 43 grams of magnesium. Stop it, Microsoft. And for every 1 mole of magnesium,
Are you going to write those out on the test? Because just you writing those out helped a lot.
no.
Okay.
You're welcome, but no.
Fingers. Like I saw that, I'm like, oh, okay.
Where did that 24.305 number come from?
Yeah,
Okay, so what's this first step do for us?
counts.
Counts the number of magnesium atoms we've got. Okay, so I've got magnesium here, and I'm gonna, it doesn't really matter, I'm gonna go to copper, and it's 1 and 1, and where do the 1 and 1 come from? The equation, which is balanced as is, so I don't need to change anything. So what's the second step do for me?
Figure out your ratio. Yeah. Makes it proportionate.
Okay, that's not enough.
Does it count copper?
It counts how many coppers I'm gonna make. If I have that many magnesiums, I'm gonna make this many coppers. So 1 mole of copper, 63.546 grams of copper. So I've got 43 divided by 24.305 times 63.546. So 112 grams of copper. Okay. So what do I know right now?
So that's how much you created.
That's how much
Or copper.
would be created if you had enough
Right.
of the CuCl2.
So if I had enough copper 2 chloride and 43 grams of magnesium, I'd make 112 grams of pure copper.
Correct.
So let's find out if that's true by going to my 75 grams of copper chloride, copper 2 chloride. All right, so 63.546 plus 35.453 times 2. So that's 134.452. And then CuCl2, 1 mole CuCl2, 1 mole CuCl2. And what do I have to go to? I have to go to copper because I needed to compare this answer to this answer. And so 63.546, copper, and copper at 1, and copper. All right, so 75 divided by the 143 times the 63.546 equals, and it's 35. Okay, so what do I know?
Copper 2 chloride is the limiting ingredient.
Right.
Copper 2 chloride is another amino reagent. I know I'm going to have this much copper in my container, right?
75 grams
I'm gonna have 0 grams of copper 2 chloride in my container when I'm done, because it gets used all up. I'm gonna have some leftover magnesium, and I'm gonna calculate how much magnesium chloride I'm gonna make. So I'll start here with 75 grams of CuCl2, 134.452 grams CuCl2, 1 mole CuCl2, and 1 mole CuCl2. And then up top I'm going to need to put 1 mole of magnesium chloride, 1 mole of magnesium chloride, and magnesium chloride. And so the magnesium chloride is 35.453 times 2 plus 24.305. So this is 95.211. Okay, so that times 75 divided by, I got 53. Okay. So I've got 0 grams of copper 2 chloride, I got 35 grams of copper, and I've got 53 grams of magnesium chloride. How much magnesium is left over?
30 grams.
30 grams? So I started with 43 grams of stuff and 75 grams of stuff. So I've got 118 grams of stuff went in, and I have made 88 grams of stuff. So that leaves me with, this is a 20 gram differential, and so that 20 grams must be the magnesium that did not react fully. Oops.
Wait a minute, isn't there 30 grams of magnesium?
Oh yeah, I can't do math today.
Okay, you confused me for a minute. And you got 88 just by taking 35 and the 53?
Yep.
Okay.
35 and the 53 gives me 88
Right.
grams of products, and since I had 118 grams of stuff put in there, the thing that didn't fully react must be hanging out.
I figured, I just wanted to make sure that's what you're getting it from.
Yeah, that's it. Volatile?
I got how easy something turns gaseous.
That's it.